Hey, welcome to the second half of the trigonometry practice exam number 1. And we're going to start off with number 8. It says name the quadrant in which the angle lies. And so in order to do this problem, we're going to remember that we have a chart for the sine, cosine, and tangent in all 4 quadrants. And it doesn't take but just a second to generate this chart if you'll remember that all students take calculus. That is a very positive statement, and that reminds us which trig functions are positive. And so that means that the other trig functions must be negative. So there's our sine chart. We know that the quadrants are numbered 1, 2, 3, and 4. And so we're looking for where sine is greater than 0. We know that things that are greater than 0 are positive. And so they're telling me that sine is positive, okay? Cosine of theta is less than 0. That means cosine is negative. Things that are less than 0 are negative. And we need to know in our chart, where do these two things happen? Sine is positive and cosine is negative only in quadrant 2. And so that is the answer to that question. Quadrant 2 is the quadrant that the angle must be in. Number 9, find the exact value of the indicated trigonometric function of theta. So in this problem, we're given that sine theta is -2/9, and that tangent is greater than 0, which means that tangent is positive. So right away, since tangent is positive and sine is negative, we know that that's going to be in quadrant 3. Okay, so whatever we get for our answer for cosine, that's going to be negative, and the answer for tangent will be positive because we're in quadrant 3. Now, let's figure this out. We need to find cosine and tangent. We know that sine theta is y over r. So here we can see that y is -2 and r is 9. What we need to find is x. So we're going to use the Pythagorean Theorem. X squared plus y squared equals r squared. Plugging in for y and r is going to give us x squared plus -2 squared equals 9 squared. And then bringing that up here, x squared plus 4 equals 81. Bringing the 4 over makes it -4. 81 minus 4 is 77. And then taking the square root of both sides to get x by itself gives us that x is square root of 77, okay? Now remember, since we're in quadrant 3, that x value will be negative. And now that I know x, y, and r, I can find cosine and tangent. So cosine is x over r, which would be negative square root of 77 over 9. And tangent, which is y over x, would be -2 over negative square root of 77. But we know a negative over a negative makes a positive, which remember that should have been, tangent should be positive, and we need to rationalize. So we're going to copy and paste the square root to the top, and then erase the square root in the denominator, and we're done. Number 10, find the amplitude, period, and phase shift, all 3 pieces. So the formula for the sinusoidal function sine, that's going to be a sine bx minus c. And we know that the amplitude is the absolute value of a, which is going to be the absolute value of -5, which is 5. There's our amplitude. Our period, the period for sine and cosine, is 2 pi over b. B in this case is 3, and that will not simplify. So the period is 2 pi over 3. And last but not least, the phase shift is -c over b, which in this case c is pi over 2 over 3. Now notice that the formula has a negative and the c has a negative. Yeah, this has a negative, so that's going to make this a positive over here. C would be positive. I think the formula actually is plus there. Okay. So anyway, what you need to remember is that if this C value, if it's negative in the formula, it's going to be positive. And if this would have been a plus, 3x plus pi over 2, then this pi over 2 would be negative in the formula. This C value is always opposite of what you see here. And then we're going to do a little keep change flip. That's going to be pi over 2 times 1 over 3, which gives us pi over 6. And if you weren't sure exactly about this process here, you could always take your calculator and you could hit fraction and then fraction again. Pi over 2. So that makes the numerator a fraction over 3. 1/6 pi is the same as pi over 6. So you can check that with your calculator if you're not sure. And that gets the 3 pieces they asked for. There's the amplitude, period, and the phase shift. Number 10 is done. Number 11, graph 2 periods. Use the graph to determine the domain and range. All right, so we have a sine function we need to graph. And real quick, the first thing we need is the amplitude, which is going to be 4. The period, we're going to need the period, which is 2 pi over b, which in this case is 5. And the phase shift, since there is no number after the x, like there's not a +2 or anything out here, since there's nothing after the x, then there is no phase shift, okay? And so we're going to go through the 6 steps of graphing a trig function, okay? First step, the starting point. Sine starts at the origin. That's the first step, starting point. Second step, phase shift. Phase shift. But there is no phase shift, so that means this point is going to stay where it is. Step number 3 is the wavelength. And the wavelength is the period. So our period is going to be 2 pi over 5. And since I don't like the way this is labeled, I'm going to change this to say 2 pi over 5. And that means that we're going to make a complete wave, a complete cycle in between these 2 points here. Okay? Step number 4 says that you need 4 spaces. So from your 2 red dots, we need 4 spaces. So we're going to have to cut those in half. Step number 5, lay out your points. And step number 6 is connect the dots. So to lay out your points, notice that for this function, we're going to start at the origin. and the number in front of the trig function, the coefficient, is -4, which means at the first hash mark, we're going to be at -4, and then we're going to return to the x-axis. At the next hash mark, we're going to be up at +4, and then we're going to return to the x-axis, and then connect the dots. Gets us a one complete wave, or you could say one period, in a distance of 2 pi over 5. Now it says graph 2 periods, so we're going to rinse and repeat, okay? So next hash mark, we're going to go down, up, and down, like so. And so if the first period was 2 pi over 5, then another period would double that and make that 4 pi over 5. That would be your endpoint of your second period, your second wave. Now then, for the domain and range, we know that this graph is going to continue infinitely in both directions. So the domain of any sinusoidal function is going to be -infinity to infinity. And for the range, the lowest that this graph ever gets to be is -4. From the amplitude, see, it's never going to go below -4, but we use a bracket because it will get to -4. And then the highest that this graph ever goes is 4. And it does touch at 4, so we need a bracket. And so there's the domain and range and the 2 periods done. Next, number 12. Find the amplitude, period, and the phase shift. All 3 of those needed. And we're going to graph the function showing at least 1 period. All right, so here we go again for the amplitude. That's going to be the absolute value of -4, which is 4. We're going to need the period. And since it's a sine or a cosine, the period is 2 pi over b, which in this case b is 3. And that won't reduce or simplify. And the phase shift, okay, -c over b. So c is +2. So over here it's going to be, c is positive pi over 2. So over here it's going to be negative pi over 2 over 3. And if we do the math and simplify that, that's going to be negative pi over 6. And I think we did negative pi over 2 over 3. Yeah, we already did that one time over here, so same thing. So there's your amplitude, period, and the phase shift. And again, we're going to go through the 6 steps of graphing a sinusoidal function. Step number 1 is, where does it start? Okay, do we have sine or cosine? We have sine. Sine starts at the origin. Okay, that's the first step, is to locate that starting point. If it would have been a cosine, then we would start at the number in front, and so our dot would be at -4 to start if it was cosine. But it's not, it's a sine. Step number 2 is the phase shift. The phase shift, okay? We do have a phase shift. It is negative pi over 6. And so that means that our first dot is going to shift to the left negative pi over 6. Okay, so do you see I'm going to change? I don't like the way this is numbered, so I'm going to change it to negative pi over 6. And this starting point actually gets shifted to negative pi over 6. So now that's the starting point. Step number 1, starting point. Step number 2, shift it if you have a phase shift, okay? Negative phase shift goes to the left, Positive phase shift goes to the right. Okay, next, number 3 is wavelength. Length, TH. There we go. And the wavelength is the period, which is 2 pi over 3. So to figure out where that end point is going to go, we're going to have to travel a distance of 2 pi over 3. And so my question to you is, how many pi over 6ths does it take to make 2 pi over 3? How many sixths of a pi's make 2 pi over 3? Well, I think it's 4. 4, but because if you notice, 4/6 reduces to 2/3. So it's going to take 4 pi over 6 to equal the period, which is 2 pi over 3. Now, why do I ask that? It's because I'm starting at negative pi over 6. So that means from here to here, that's a distance of pi over 6. And then this would be positive pi over 6. This would be 2 pi over 6. This would be 3 pi over 6 if I change that, okay? So the wavelength is 2 pi over 3, and it's going to take 4 pi over 6 to equal 2 pi over 3. So from our starting point, we're going to go 1, 2, 3, 4. And that means we're going to end at 3 pi over 6, which that actually reduces to pi over 2. We're going to end at pi over 2. And 2 pi over 6 reduces to pi thirds, just so you know that, okay? So let's get rid of this stuff. There we go. And we're going to end here. This is our starting point. This is our end point. This represents a total distance of 2 pi over 3. And remember, step number 4 says that you need 4 spaces, 4 equal spaces. So this is going to be 1, 2, 3, 4. 1, 2, 3, 4 spaces. And the reason I need the 4 spaces is because the hash marks are where my points go. Step number 5, lay out your points. Now we have a sign. Remember, we're starting on the x-axis, and the number in front originally was negative. So at the first hash mark, we're going to be at negative 4, and then we're going to return to the x-axis. At the next hash mark, we're going to be at positive 4, and then we return to the x-axis. Okay, so that's lay out your points. Step number 6 is connect the dots. Okay, down and up and down. And that gives us 1 period. And it does say show at least 1 period. And there's 1 period of the way. Okay, and that is done. Next, number 13. Determine the period of the function. And then it says graph at least 2 periods showing any asymptotes as dashed lines. And so this time we have a tangent. This is not sinusoidal. So this has a 4-step process. Step number 1 are the asymptotes. And we know that for tangent, our asymptotes, or at least 2 consecutive asymptotes, are going to be bounded between negative pi over 2 and theta and positive pi over 2. This is the way that you set up and find your 2 consecutive asymptotes. Theta goes in the middle. It's always negative pi over 2 to pi over 2. And then we're going to have to solve for x. And to solve for x, we're going to multiply everybody by 4. And that's going to get my 4's to cancel. Okay? So 2 goes into 4 2 times. That's going to be negative 2 pi less than x and 2 pi. So that's going to give us 2 consecutive asymptotes. And I'm going to have to extend this over just a bit. My graph was not big enough here. Bam. So that's half a pi, 3, and 4. So there's negative 2 pi. And so we're going to have an asymptote at negative 2 pi and at positive 2 pi. Those are consecutive asymptotes, okay? That's step number 1. Step number 2, you're going to have an x-intercept in the middle of the asymptotes, okay? Step number 2, x-intercept right in the middle of the asymptotes. Step number 3, at the first and third quarters, you're going to have y values of negative a and a, respectively, okay? Now, what does that mean? That means that if you look between the asymptotes, the x-intercept is halfway, and then if we cut that up into quarters, 1, 2, 3, 4, if you cut it up into 4 spaces, those are quarters. And so at the first quarter, you're going to have a y value of negative a. Well, a is already negative, so that's going to make that positive 2. You're going to have a y value of positive 2. And at the third quarter, you're going to have a y value of a, which a is negative 2. And those are going to get you 2 other points. Always at the first and third quarters, you're going to have y values of negative a and a, respectively. And then step number 4, we're going to connect the dots. Okay, so the asymptotes are the boundaries, and the graph is going to come in. Approaching the asymptote is going to come in. It's going to kind of do a squiggle through these points here, and then it's going to come down and approach the other asymptote. So that is one period of the function. They want us to graph at least 2 periods. And so we're going to extend this out just a bit, and I'm going to have to scrunch it to make it fit here, okay? Now notice the distance between asymptotes is 4 pi. Negative 2 pi to 2 pi, that's a total distance of 4 pi. So if I want to go another asymptote, that's going to be 2 pi. I'm going to have to go 4 pi, 2 pi, 3 pi. Right there. 1, 2, 3. Yep, I'm going to have to scrunch it. Dun, 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 dun. All right, so if this is 2 pi right here, and this is negative 2 pi, and this distance here is 4 pi, then this distance has to be 4 pi, which means this would be labeled 6 pi. And then we're going to go halfway in the middle, and then at the first and third quarters, we're going to have the dots kind of like it copy and paste over here. And then we're going to have another period, okay? And again, this point right here is going to be 6 pi. I had to scrunch it in there, which means that in the middle, this would be 4 pi, 2 pi, 3 pi, 4 pi, 5 pi somewhere here, and then 6 pi. Got it? Okay, what else do we need? We need to determine the domain and range. All right, let's get the domain and range. So we're going to say the domain is the set of all x such that x cannot be equal to 2 pi times k, where k is an odd integer. Okay, now here's why that is, okay? If you think k is an odd integer, then 1 would be like the first value of k would be 1, and 1 times 2 pi is 2 pi. So that's an x value that you can't have because there's an asymptote. And then what is the next odd integer after 1? Well, it's 3. And then if I plug in 3 times 2 is 6, and that gets me the next consecutive asymptote where x cannot be. So this is the way the domain is going to need to be written to account for all of the asymptotes, which are values that x can't be. That's going to be your domain. And then for your range, it's going to be everything from minus infinity to infinity, because if you look at these waves, the graph is going to go down forever. It's going to go down to minus infinity, and it continues to go up forever up to positive infinity. So it covers all the y values. And that's going to do it for number 13. All right, here we go. Last problem, number 14. Graph at least 2 periods of the function, showing any asymptotes as dashed lines, and we need at least 2 periods. Now this time we have a secant, and we know that secant is related to cosine. So we're going to follow the 6 steps for graphing a cosine, and then show you at the very end there's a slight difference to get your secant graph. Okay, so here we go. We're going to need the amplitude, even though a cosecant doesn't really have an amplitude. Remember, we're pretending that it's cosine. The amplitude is 2. We're going to need the period, and for cosine and secant, that's going to be 2 pi over b, which is a fourth. That's going to be 2 pi over a fourth, which is really going to be 2 pi times 4 over 1, which is going to be 8 pi. And the phase shift, which we do not have any number added or subtracted after the x, so there is no phase shift. So we don't have to worry about a phase shift, okay? Now then, the 6-step process for graphing a cosine function is step number 1. Do we have sine or cosine? And we have cosine, which starts at the number in front. So cosine is going to start on the y-axis, but it is going to start at the number in front of the trig function. That's step number 1. Step number 2 is phase shift, which we have none, so we can skip that. Step number 3 is wavelength, which in this case is 8 pi. And so I'm going to have to renumber this again because it's just not numbered correctly. Okay, so we're going to say this is 4 pi, and 4 pi is 8 pi, 12 pi, 16 pi. We're going to renumber that, okay, which means this is also negative 4 pi now. All right, so our wavelength is 8 pi. And if we start at 0, that means we're going to finish at 8 pi. That's going to be a wavelength, starting point to end point, and you always finish where you start. So if I start up at 2, I'm going to finish up at 2. Step number 4, I need 4 spaces. And I've got on here 1, 2, 3, 4 spaces. Step number 5 is lay out your points. And since I'm starting up at 2, at the first hash mark, I'm going to hit the x-axis. At the next hash mark, I'm going to be at -2. At the next hash mark, I'm going to be back at the x-axis, and then I'm going to finish up at 2. So there's my layout, my points. And then step number 6 is where this is going to change, and we're going to have to remember that we're really doing secant, okay? So if this was a cosine, we would actually connect the dots something like that, okay? Making a wave. But this is a secant. So what the secant says, it says that every x-intercept becomes an asymptote, and the other dots are going to be points on these curves here. Okay? And then this guy going up here. So your highs and lows are going to become the points of what I call your humps and bumps, okay? And that is almost 2 periods. We need one more period here. So I've got an asymptote at every 2 hash marks. So there's going to be an asymptote there. And then if I continue this pattern, this is going to be down here. Whoops. That should be a red dot. Down here at -2. And then we'll have another asymptote here. And another curve there, okay? So do you see that these are going to continue to alternate curves up and down every 8 pi is the wavelength, okay? So you're going to have a down hump and an up hump, and that's going to cover a distance of 8 pi. And that's it for that problem. That is graphing at least 2 periods of the secant. So that's going to conclude the review for practice exam number 1 for our trig class. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.